Okay, good afternoon. Welcome everybody to the virtual event, Volcanic Monitoring in the French and Dutch Caribbean Islands. Today, we're happy to have here to Dr. Elske van Dalfsen and from the Royal Netherlands Meteorological Institute and the Dr. Jean-Christophe KOMOROWSKI from the Institut de Physique du Globe de Paris, from University of Paris. Okay. Dr. Elske received her master's degree in geology from the British University in Amsterdam, in Netherlands. For a year, she worked at several volcano observatories around the world, as Hawaii, Philippines, Indonesia, Iceland, and learning all about the monitoring of volcanoes, as well as crisis management and communication with the government agencies. In 2005, she completed the PhD at the Open University in Milton Keynes, United Kingdom, and specialized in volcano geodesy. And at the Royal Netherlands Meteorological Institute, she's tasked with the monitoring. With the monitoring volcanoes Mount scenario and the Quill in the Caribbean Netherlands. Also, we have here to the Dr. Jean-Christophe KOMOROWSKI. I'm so sorry for the dog. He's from the Institut de Physique du Globe de Paris. And he is professor at the Institut de Physique du Globe de Paris. The doctor is a geologist specializing in physical volcanology, monitoring and assessment of volcanic hazards and risks. With 30 years of experience, he's a scientist in charge in the IPGP's volcanological and seismological observatory since 2016. And he serves 5 years as scientist in charge of the Observatory Volcanologic and Seismologic of Guadeloupe, as interim rotating director for the Montserrat Volcano Observatory between 2008 and 2010, and the Observatory Volcanologic and Seismologic of Martinique between 2022 and 2024. He's also responsible of the French National Services for Observation and Volcanology. And he was investigator at the UNAM at Mexico between 1991 and 1993. Today, we will start with Elske. So I will give you the words. So please go ahead, Dr. Elske.
Yeah, hello, welcome everyone, and thank you for this introduction, and thank you for joining us today. And I'm gonna take you to the Caribbean Netherlands and talk about the volcano monitoring that we do there. And first of all, I would like to thank my co-workers, Reinhard Sleeman, who is a seismologist, and Andreas Krietemeyer, who's a geodesist, also at KNMI. And the photo that you see here, this is the island of St. Eustatius. And in the back of the island there, you see the volcano, the Quill. Now, KNMI is the Royal Netherlands Meteorological Institute. It's located in the Netherlands. And the volcanoes in the Caribbean are actually 7,800 kilometers away. So you may be able to imagine that it's not always so straightforward to run a monitoring network that is located so far away. The department that I work at is the Department of Seismology and Acoustics, and it's the responsibility of this department to give timely warning of geophysical phenomena, such as earthquakes, tsunamis, and also potential volcanic unrest. In the Caribbean, there are 3 islands that are special municipalities of the Netherlands. And these 3 islands are here circled in green. They are the islands of Bonaire in the south. And then in the north, you can see the islands of St. Eustatius and Saba. And the 3 of them are also referred to as the BES Islands. Now, for this talk, I will focus on Saba and St. Eustatius because those are the islands with a volcano. These islands are actually very small. You can hardly see any island within the green circle. And that's true. I mean, Saba has a surface of 13 square kilometers, and St. Eustatius has a surface of around 21 square kilometers. So they're very small islands, and the combined population on both of these islands is around 5,500 people. The islands are part of the Lesser Antilles volcanic arc, and this volcanic arc is the surface expression of the subduction of the American plate under the Caribbean plate. And you can see that Saba and St. Eustatius on the image on the left, if we look at the chain in more detail, you see these islands are located at the far north. And on Saba, we have the volcano, which is called Mount Scenery. And on St. Eustatius, we have the volcano, which is called the Quill. Now, later today, I think my colleagues will be talking about volcanoes on Guadeloupe and Martinique. And we also see, maybe you have heard about the volcano on Montserrat or the volcano on St. Vincent, which erupted most recently in this area. Let's go to Saba. So this is how you approach the island. You see the airport lying in the middle of the island there. And when we look at the Google Earth image of the island, we see several things. So in the northeast, that's the airport that you just saw from a different angle. And in the southwest, that is the harbor. It's a harbor for freight, ferry, and also fishing vessels. But the thing is that to get to the harbor, you need to go down this very, very steep road. And this road is often blocked by rock falls, especially during times of heavy rainfall. Now, there are 4 villages on the island. As you can see the roofs, the red roofs of the houses. And these villages, they are connected by a road, which is conveniently called the road. And also the road can be blocked by rock falls during periods of heavy rainfall, and then it's very difficult to get around on the island and also to basically evacuate if you'd have to evacuate. Now this is the capital city of Saba. It's called the Bottom, and on the left side you see a small stretch of the road, and then what is very evident is these huge domes that are surrounding the capital city, and we see more of those a bit later. Now let's go to St. Eustatius. It's also called Statia by the locals, and this is the landing strip there. It's a little bit larger, and if we look at Google Earth image, we can see it looks actually quite different. So apart from the airport, we also have there 2 harbors, one commercial harbor and also a harbor at the oil terminal. And then we see on the south side of the island, we see the volcano called the Quill, which has the lowest side of the rim actually towards the capital city. There's only one main city on the island, and that's the city of Oranjestad. Now, the north side of the island is uninhabited, and it's built up of old volcanic centers. And this is a photo of the capital city of St. Eustatius, Oranjestad, part of it. And you can see the volcano in the back. So now you have a little bit of an idea of what these islands look like. Mount Scenery on the top, it is reaches about 870 meters elevation. It's covered by tropical rainforest. And here in the middle, you can see the lava flow that hosts the airport. It's the shortest commercial strip, landing strip in the world. It's only 400 meters in length. And Saba is really characterized by a very irregular, steep topography. And this is caused by all these domes that you saw in this previous photo, and you can also see it in this image here. Now, the image in the bottom shows the Quill volcano on St. Eustatius, and this volcano only reaches about 600 meters. It's also covered by a tropical rainforest, but it's really one main stratovolcano. So it's in that respect very different from Saba. Now, there are no historic records about an eruption of these volcanoes. So all we know is there was some dating work done in the 90s on a few samples, and these suggest that the last eruption of Mount Scenery occurred around 1640, and in the Quill, the last eruption was potentially around 400. But these dates are relatively uncertain. Nevertheless, these volcanoes are, geologically speaking, classified as active, but quiet volcanoes. The deposits indicate that earlier eruptions were very explosive, similar to the ones of St. Vincent in 2021. And we also know that volcanoes in this arc can erupt after many years of quiescence. Think about the eruption that started in Montserrat in 1995. So the question is not if, but rather when and how these volcanoes will erupt. An important note is that maybe this won't be during your and my lifetime. But nevertheless, monitoring seems a very good idea for these volcanoes. So that's why we run and operate a monitoring network on these islands. And our monitoring network consists of broadband seismometers. We have 11 of them, and we started operating them since 2006. We also have a network of permanent GNSS stations, which we started in 2018. We look at thermal data. For example, here in this photo, this is the hot spring on Saba since 2018. And last year, we started campaign GNSS measurements also on both islands. And this is actually to densify our measurements. Apart from that, we also run a pilot with 4 cost-effective GNSS units on Saba. You see them here in the photos. And these cost-effective GNSS units log dual frequency GNSS data. Each unit costs around 1,000 euros or less than 1,000 euros. And this is about 10% of what a normal permanent GNSS setup costs. So it's a lot cheaper. The first results look very promising, and a publication about this is in preparation. Now, where are our monitoring sites located? So each triangle here shows one of our setups, and we try to locate them as well as we can around the volcanoes. Of course, one difficulty here is that part of the islands are uninhabited, and it's then also not so easy to install monitoring sites in these areas. So the green triangles indicate our off-grid stations that are located in areas where there is no power supply and also no reception. So what does a monitoring off-grid monitoring station look like? This is the one on St. Eustatius. And you see in the photo on the top left, that's before there was anything, and the photo on the bottom shows what it looks like now. So we have a satellite dish for communication to send the data to KNMI. We have a concrete housing that is used for the broadband seismometer. We have solar panels that produce the electricity, an electronica cabinet that houses not only the electronics for the solar panels and the VSAT, but also our GNSS receiver. And on the far right, you see the tiny white thing, that's our GNSS antenna, which is located and installed on the only big, huge rock that was available in this whole area. So you can imagine that installing these off-grid stations is not always straightforward. And without the help of Corps Mariniers and the local government, this would not have been possible, as around 2,000 kilos of building materials and tools were carried up the mountain to make this happen. Now, this is some of our, shows the data availability for our monitoring network in 2023. On the left, you see that for the GNSS data, and on the right for the seismic data. So the daily data availability for the GNSS data is more than 98%. The main problem stems from early 23 when we had power issues at our off-grid site, Saba and St. And this was solved by installing an extra solar panel later in 2023. So this has helped to solve this for the future. Now, if we look at the seismic data, we have had a bit of bad luck with some broken hardware for stations Sub-W and station SEUS, and also some network challenges for the station that we run on St. Maarten. But the availability for the well-running stations is above 95%. Data from 7 out of the 11 KNMI seismometers are sent in real time to KNMI, and the rest becomes available within 2 days. And that's due to the VSAT transmission of these sites. The seismic data from other international organizations, so from some of our colleagues that are online, they are then included in the data analysis. And the location and magnitude, they are automatically calculated. And this is then followed by manual analysis by a seismologist who's on duty 24/7. The data are publicly available through Orpheus, and I would encourage use of those data. This is what a local tectonic earthquake looks like in our recordings. So we use SeisComp and also a coincidence trigger to analyze and help us detect the different earthquakes. This one happens to be from October 2020 and occurred around 50 kilometers from Saba at a depth of 10 kilometers and had a magnitude of 4.8. Now this way, I see this figure is not loading, now it is. This way we build up a catalog of earthquakes, and you see in the image on the left, that's the catalog between 2017 and 2022, where the color says something about the depth of the earthquake and the size says something about the magnitude. And we are mostly focusing on earthquakes within 100 to 150 kilometers from the islands, which are located in the middle of this circle. And if we then look at the figure on the right, you see that when we compare the US catalog to our catalog, that we do pick up earthquakes that are closer to the islands. And so that's where our network helps to fill this monitoring gap. Then a little bit about the monitoring of the thermal data. So Saba especially displays some thermal features that are located in a band that's indicated in a small figure on the top left. And this band runs from the southwest to the northeast. And in this band there are several features, such as there is the sulfur mine on the left photo, the left panel, which is about 32 degrees Celsius. We monitor it with the FLIR and also with TinyTech loggers. Then in the center, you see our setup at the hot spring, which has a temperature of 84 degrees Celsius. And on the right, you see the green gut vent, which has a temperature of 37 degrees. So over time, so far, we haven't seen big changes in these thermal features, but we will continue to monitor those. Then for the geodesy, so we're looking at the permanent GNSS stations. So these data are sent daily to KNMI with a delay for the VSAT sites. we use these data together with data from other international organizations for our network processing, and the data are publicly available through Earthscope. So this is what some of our time series look like. The data are operationally processed using Bernese network and PPP processing. So here the blue dots are our PPP processing, the red dots is our network processing, and we compare that to the NGL PPP solution. And we nicely see the plate tectonic movement to the north and the east in the data from these sites. This happens to be the off-grid stations on Saba and Statia, but the others show the same features. What we then do is we take the airport station and use that as a baseline, and then compare it to the other stations to look for more local deformation. And each color is actually a different station. So you can see that towards the end, we get more and more colors at the same time, because we're finally completing our network of GNSS stations. And we also see that there is really no local deformation. It's mostly around the zero line, which is good news for us, because it means that the volcano isn't moving. Yeah. Then one other thing I wanted to mention is that sometimes there is Sahara sand or volcanic ash or volcanic aerosols moving towards the islands. And then our colleagues actually at other departments within KNMI are looking at weather models and satellite observations to distinguish between these two. And that's really helpful, because the people on the islands want to know why they see no horizon, and if they should warn people with asthma about the dust or volcanic aerosols in the air. And in this case, it was actually due to the eruption on La Palma in the Canary Islands that these volcanic aerosols came all the way to the islands in the Caribbean. Now we use, as most volcano observatories, we use an alert level system, which in our case has 4 tiers and goes from normal green to warning red. And the alert level is established based on instrumental data and observations. And currently, both volcanoes are in alert level normal or green. Finally, I'd like to point out where you can find more information. So the most recent reviewed earthquakes, they can be found in this link here. And please take note that you have to go to the tab Caribisch Nederland right under the map that you see there. And then you get a whole list and you can find the details of the earthquakes that we reviewed. You can also see the live seismograms. That's on www.knmidc.org/seismology. And you can find the current alert level and more background info, the same website, but /volcanoes. And I think that's all I wanted to say. If you have any questions, don't hesitate to drop me an email at dalfsen@knmi.nl. Thank you very much.
Thank you very much, Doctor. So now, if you have any questions, you can raise your hand or just put it in the chat and I can read it for the doctor. So please go ahead. Or also, there you have the doctor's email. So if you want to ask her for anything or ask a question, you also can do it. Okay, let's wait. Someone give us a question. Oh, I also want to remember you that the presentation will be available in our Albos YouTube channel. So if you want to check again or share with someone, whatever, you are free to do it. Jean-Christophe have a, oh, he writes.
Yes, Thank you very much. Thank you, Elske, for this very nice presentation. I have a question which probably will interest my colleagues in Guadeloupe and Martinique. Can you say a few words about the monitoring of the submarine fumarole or gas emission site?
You refer to the one we monitor is actually at the north side of the island, and it's right on the shoreline. So the spring is submerged some of the time, and it's dry some of the time. I mean, I've only been there once when it was dry, and other times it's been under like 30 centimeters of water. And we have 2 tiny tech sensors in there with loggers that log every 20 minutes the temperature. And to keep the sensors in place, we use a fish net with rocks, because otherwise they don't stay in the source basically. And that has worked pretty well. And we tape the sensors with the chemical and heat resistant tape, because the first few times our sensors were eaten by the chemical reaction. So we tape them, and that has also helped very well. I think the most difficult thing is to get down to the site to collect the data, because it's down a very, very steep cliff for about 250 meters. And the boat access is also very difficult because there's a very strong swell and waves there. So, but we're getting some help this year, hopefully from the military, to secure the hiking path to go down to these springs.
Okay, thank you very much. Have you ever been able to collect gas from, is just a water spring or dissolved gases from the water?
Yeah, we've tried to do this. Our student from Canada, from McGill University, has tried to collect gas, because some people have seen bubbles there. I have personally not seen any bubbles, and the student was not successful in collecting measurable gases.
Okay. Thank you.
Yeah.
Thank you so much, doctors. Okay, while someone else raised the hand, I have a question actually. You mentioned that there are no historical reports of activity in these volcanoes, but you mentioned also to approximate dates.
Yes.
How do you determine?
Yeah, so the dates are from carbon-14 dating that was done in the 90s. The difficulty is that European people arrived on the islands around 1640 and 1645. So, of course, if you do charcoal date, there is not so much charcoal, because most of the eruptions, when there were big pyroclastic flows, it took all of the wooden material into the sea. So it was washed away. So they haven't really found much material to date. And then what they find, of course, it's difficult to know for sure that it's from the last volcanic eruption. So, but this is what is there, so we have to use it. It's definitely clear that there were explosive eruptions, and that it's not crazy long ago. We can say that, but very, very precise. We would need more research, I think, to be sure on these dates.
Okay, I see. Thank you. Okay, that's interesting. Thank you again for this interesting presentation. I think we have no more questions. In any case, if you have more questions, you can write to the doctor. And
Yes.
so we will go ahead with Jean-Christophe and his colleagues. Thank you so much.
Thank you very much.
So now I will give you the control, doctor.
Okay.
Let's go ahead.
Okay, do you see the presentation? I will put it in full screen mode.
Okay, we can see, yes, it's in full screen now.
Okay, let me go back one. This way. Okay, thank you very much for this opportunity to present the volcanological and seismological observatories of IPGP, and we will do this with 3 parts. I will present an overview of these observatories from the IPGP. And then my colleagues, Ivan Vlastelik from Guadeloupe and Jérôme Verne from Martinique will present their observatory in their respective islands. So IPGP is one of the largest university-based research centers in France that is entirely focused on earth science, the planets, and the environment. And as such, it operates several world or global geophysical networks, including world seismology, geoscope, and then magnetic observatories, intermagnet, and also the volcano observatories. And these observatories are located in 4 different places. So as Elske mentioned, this is also far away from the home institute in Paris, but the observatories in Guadeloupe, Martinique, and La Réunion are full-based research and monitoring laboratories with specific staffing to carry out the majority of all the tasks of an observatory. So you can see the 2 observatories in the Caribbean, but I will give you a general perspectives because we, of course, have an observatory in La Réunion and also a network that is operated by several institutes, but that is under responsibility of IPGP in Mayotte, because a few years ago, there was a new volcano, a new active volcano was born in Mayotte in the Indian Ocean. And therefore, France had to set up with other institutions an entirely new network to monitor this activity. So we're spread in many locations, but there's also an entity in Paris. But most of the staff is in the volcano observatories in the overseas territories. I won't go into the details of all the slides. You can have those as support material, but of course we have all the objectives of the standard objectives of volcano and seismological observatories listed here. So obviously we're operating networks to establish a baseline reference level. We need to monitor the evolution of this baseline level and detect changes in behaviors or trends, determining the activity levels and the system criticality. This involves issues of thresholds and perhaps precursors. Of course, we work on conditional probability assessment of the occurrence of surface phenomena, and we have to transmit the information to the authorities in charge of civil security in terms of scientific alerts. We obviously contribute in our observatories to knowledge leaps via fundamental research on volcanic systems, and we also of course, disseminate regular information and knowledge to all stakeholders and to the general public with the aim of raising awareness and preventing risks. So again, no details here, but just to tell you that overall, the VSO of IPGP is about 72 people. It's about 45 full-time equivalent persons, and about 80% of the staff is located in the overseas regions of France, so La Réunion, Guadeloupe, Martinique, and also people involved in Mayotte. And only about 20% are based in Paris. But of course, these observatories benefit from the entire research structure of IPGP, which is about 500 people and has very extensive modern analytical facilities. In terms of the budget, the important aspect is that about 70% of our non-salary funding comes from competitive funding. So we have to pursue every year different sources of funding in order to secure 70% of our funding beyond salaries. Salaries are paid by the government. So it's quite a load on our structure to look for this additional funding on short-term, one year basis, and so that's one of the weaknesses of our system. But the average budget, yearly budget, is about 1.7 million euros per observatory, including the salaries, and excluding the salaries, it's about 500 to 600,000 euros. In terms of activity, we've been quite busy in the last few years because actually it's quite remarkable. All of the active volcanoes of France are in either a state of unrest or a state of eruptive activity. Ivan and Jérôme will talk about the unrest in Guadeloupe and Martinique. We have had, in the last 6 years, 19 eruptions at Piton de la Fournaise, which is a hotspot volcano in the Indian Ocean. And of course, we had this new volcano that was born in Mayotte. Is a 900-meter tall volcano. It produced the largest effusive eruption since 1783 in Iceland, and probably the largest known effusive submarine eruption with about 7 cubic kilometers that was emitted in basically 2 years. And that has triggered a real change of paradigm in terms of evaluating volcanic hazard on the island of Mayotte, which is in the Mozambique channel between East Africa and Madagascar. And interestingly, this reactivation of the Mayotte volcanic zone is probably occurring after several millennia of inactivity. So obviously, we have lots of collaborations. In purple, you see here the collaboration that we have in the Caribbean with SRC, of course, KNMI, and then also institutions in Cuba, Venezuela, and Haiti. And we are hoping to develop interactions with ALVO, and this presentation comes in the context of discussions that we've had in the last few years between colleagues with ALVO and also within the Caribbean. One important aspect of our system is that we rely on a computer-based platform that allows to do a lot of tasks for observatories in terms of recording all the data of all the stations of the network, performing station maintenance and recording all the actions on the stations, and doing this in real time. It allows to process the data. There is some integration of modeling capabilities. And so it's a real important asset that was developed by François Baudicel and colleagues. It's called WebOps. It's been 20 years in action, and it's starting to be implemented in different observatories in the world. So this is our daily workhorse, daily tool to manage activities of the observatory at different levels. Monitoring networks, we have permanent networks, about 276 stations on all of these observatories. You can see the distribution of the different types. In purple is seismology, in red is deformation, and the rest are the other observables. About 7% is geochemistry, and seismology and deformation accounts for 81%. And these are telemetered continuous stations. We also have reiteration networks with about 600 monitoring sites that we reiterate at different time scales. And you see that most of these sites are for geochemistry, about 250 sites, and about 200 sites for repetition GNSS measurements in the different observatories. And we also have temporary seismic antennas or node experiments on the different volcanoes. We of course function with an alert level system. It's a bit different for La Fournaise. You can see on the left, La Fournaise has a slightly different system because eruptions there are more frequent and they can develop in a very short time scale. And Ivan and Jérôme will give you more detail about the state of the activity in Guadeloupe and Martinique. In Mayotte, we are working to implement a new alert system, but this is all very new and there's still no volcano response, emergency response plan. So that's in the making, in the development phase with the authorities. Of course, we publish all the standard types of reports on different time scales. You can get back to this information later on, but we have daily bulletins, weekly bulletins, in some of the observatories, of course, monthly bulletin in all the observatories. We have exceptional event bulletins for felt earthquakes or other events. We issue VONA reports, actually only now in Piton de la Fournaise in La Réunion, but we are set up to do that in the Antilles. And we, of course, have eruption bulletins and annual reports. And for the first time in Mayotte, we were able to disseminate our information in a one-page, you can see here an example graphic, mixing graphics and photos and a little bit of text in 3 different languages, French, and also the 2 spoken languages, Kibushi and Shimaore in Mayotte. So that is kind of a new development that we're very happy of. And this was done in collaboration with the University of Mayotte. Of course, we contribute to volcano crisis response plans under the responsibility of the prefecture, the local authorities, and our data, our assessment are included. You can see some examples in terms of hazard maps or scenario-based maps. And this is an important part of our activity. And we also are involved with these authorities in eruption, earthquake, and tsunami crisis exercises, including the well-known Carib wave exercise. And a few years ago, in 2023, the Carib wave experiment exercise was related to a volcano tsunami scenario linked to collapse of Mont Pelé. So we work with the authorities. Many of you in the Caribbean played this scenario that was proposed by the UNESCO, and we refined our operations and practice also this particular type of scenarios. So I will not get into the details of the Antilles observatories. Just to tell you that in La Fournaise, for example, there are 12 people in the observatory, and it's split largely 60% engineers and then technicians and researchers. In Mayotte, we have set up a new network on the request by the Prime Minister of France in 2019, and this was the first time that the role of monitoring and transmitting alert was clearly written on the document, because up to then we've been operating under the agreement that IPGP has observatory networks. We provide observations that could help mitigate risk, but we don't have the official risk assessment mandate, such as the USGS, for example, or like the Meteorological Agency. So in Mayotte, there was a new status was achieved, and it's still in the implementation stage. So there is no observatory in Mayotte, but the operational monitoring is done by the observatory in La Réunion, in Fournaise. But we were able, for the first time also in the history of IPGP's observatories, they date back many decades and even a century in the past, we were able to have 6 new recruitments specifically targeted at the IPGP for the Mayotte crisis. So that was also quite an important achievement. So I'm not going to go in greater details. Of course, Mayotte is a big challenge because we need to have land-based networks, marine networks. You can see here the triangle is the new volcano, but there's a very large chain of volcanic domes, cones, and stratovolcanoes that has been reactivating much closer to the Mayotte island. So you can see the challenge, and IPGP is therefore venturing in new areas of active submarine volcanism monitoring. And this involves, of course, a lot of oceanographic campaigns. But all of these new developments benefit, of course, the observatory in the Antilles. So I'll stop here and I'll let Ivan and Jérôme take over for Guadeloupe and Martinique. Thank you very much.
Ivan, you start or I start? Your mic is off. Okay. So I can perhaps start with Martinique, okay? So I will try just share my screen. Hello everybody. Hope you can hear me well. I will just give a brief introduction to the Volcanological and Seismological Observatory of Martinique. I'm Jean Verne, and I am the new scientist in charge for this observatory since about 2 months now. And what I will present is, of course, mostly the work of numerous collaborators from OVSM here in Martinique, but also from other collaborators in Paris. The Martinique Observatory has a quite long history. I mean, it was the first observatory was founded in 1902, just after the major eruption which destroyed Saint-Pierre town. Then it stopped, and it started again after the last eruption in 1935. And since then, it has been operated continuously. Recently, about 4 years ago, we moved to a new building, which is about 2 to 3 kilometers from the last one. You can see a picture here on the right, and it's really nice facility for the team here. And of course, we have the ability to welcome collaborators, and you are, of course, all welcome to visit us in our new nice building. But presently, our permanent team is made of about 11 people, including 2 researchers. We have observatory duties, but also engineers, IT guys, and administrative people. And our main task and main missions are the same one as for the 3 OVS or the 4 OVS that Jean-Christophe presented before. One of our tasks is to monitor the activity of the active volcano, which is Montagne Pelée or Mont Pelée here in Martinique. We also have the duty to do the monitoring of the regional seismicity. We contribute to the upward alert for the Caribbean tsunami early warning system with 4 stations, with 4 seismic stations belonging to the WI network. We try to do and participate to research projects and have numerous collaborations, and we do dissemination of information to authorities and to the public. One specific aspect of the OVSM is also the maintenance of an automatic LAR detection system for river, which is close to the Mont Pelée, which is the pressure river, and which had numerous density flows during the past years. So to do that, our monitoring networks is quite dense, actually. Over the whole Martinique, we have about 46 permanent sites, sometimes with multiple instrumentation to do all these monitoring activities. And of course, it is there's a concentration of instrumentation around the active volcano, Mont Pelée, where we have 11 broadband stations, one shot period 1. So you can see them with the triangles, with the gray triangles. We have also 9 permanent GNSS stations, and we do some campaign and yearly remeasurements of about 30 sites. We do have tight tiltmeters in a borehole, but which are presently out of service. And we do also some sampling of springs and boreholes and water in boreholes. We have about 66 sites that we sample regularly, and also 1 near coast offshore degazing site, which is here. And for the LARs in the pressure river, which is located to the west of Mont Pelée, we have 3 geophones, AFM geophones, plus 1 pendular system here and 1 hub within the town with an alarm to alert the population when there is a LAR coming. And as Jean-Christophe was presenting before, most of our visualization, daily analysis of the data from these networks are done with the WebOps software and platform. We have also other facilities. I just concentrate here on 2 aspects. For geochemistry, we have various, I would say, quite typical equipment in volcanic observatories with temperature and pH, digital sensors, thermal camera, titrators, and also we do have a ionic chromatograph and also an accumulation chamber to measure soil, CO2, and H2S flux degazing. Recently, within the framework of an Interreg project, we are able to build a marine platform to be able to do some surveys and observation offshore. And this platform is made of mostly 4 main equipments, which is a multi-beam echo-sonder to do some precise bathymetry. We also have remotely underwater vehicles that you can see to the right, which allows us to do some movies, pictures, and take samples up to 200-meter depths. There's a prototype also of a broadband OBS that can be really easily deployed with a small boat with only a small team, and which can measure for about 6 months. And last but not the least, we have now a buoy, an oceanographic buoy, which is in the Fort-de-France Bay with multiple sensors to sample properties of the sea. As Jean-Christophe said, I mean, observations, interpretation in various bulletins. We have a weekly report, which is available in French and English, also a monthly report and an annual report on a regular basis, I would say. And you can find all these reports in various ways on the web page of ESM, but also they are available through Facebook and Twitter X since quite a long time ago. And we do, of course, participate to various outreach activities. I don't go into the details. So just a few words about our only active volcano in Martinique, which is Mont Pelée. This volcano has had about 20 magmatic eruptions during the last 5,000 years, which means on average 1 magmatic eruptions every 250 years, which with a mix of phreatic, Pillan, and Plinian eruptions. The last Plinian eruptions were about 700 years ago, and the last 2 magmatic eruptions that you probably know occurred the last century. The most important one in terms of death toll was in 1902 up to 1905. With about 28,000 deaf people in mostly in Saint-Pierre and other towns around. And the last eruptions was almost 100 years ago, and it was phreatic and also magmatic eruptions. Since then, the activity has decreased. The fumaroles activity stopped about in the 70s. And in terms of volcanotectonic activity, it was quite quiet, except some episodic bursts of earthquakes, until I would say last April, April 2019. And I will get into some details about all the phenomenology and data we monitored since then, where we have an increase of several parameters which generates an increase of the volcanic alert system to the yellow level, which is the vigilance level, and meaning an increasing of activity, which was decided by the local authorities, the prefecture, in December 2020. So really quickly, in terms of what we call this up to now non-eruptive volcanic unrest that we consider still active today, also it's decreasing. In terms of seismic observations, we have a drastic increase of VT activity starting in April 2019. We mostly consisting of shallow earthquake, although we do have some VT at a few kilometer depths, but most of them were shallow earthquake, mostly repeaters of well-known zones of activity. As one was known for at least the 70s. We also observed some episodes of tremors and also some deep hybrid and long period events, also not very numerous. And also we had at the beginning of the crisis several events which were located in the Dominica Channel at about 10 to 15 kilometer depths that can be perhaps interpreted as some distal volcanotectonic events. Presently, the seismic activity is decreasing. but it's still over the base level if we compute it over a 6 months long average. In terms of geodesic observations, you can see to the right the deformation observed both for permanent and campaign GNSS stations, where you see clearly some deformations close to the top of Mont Pelée, which shows some radial inflation and which indicates probably that there is a shallow pressure source which is based on modelization situated 1 to 2 kilometer depths below the sediment. We don't have clear distant deformation, meaning that we don't see actually, or we don't see some deep magma transfer. And also you can see some moderate deformation on the western flank of Mont Pelée, but it's unsure if we can relate that or not to the present unrest. If you look at the baselines, you see the increase which started mid-2021, but we are getting now for most of the baseline in a decrease of the deformations. One other phenomenological aspect that we monitored are zones of degraded vegetation. The first one, so they are located on the southwestern flank of the volcano, and the first one was observed based on Google Earth images in November 2020. So when we had most of the seismic VT and tremor seismic activity. Later, we observed about 6 zones where we see some degraded vegetation, and this has been confirmed with NDVI satellite monitoring, which is a way to compare the wet band and the near-infrared band, and when you have low values, meaning the yellowish colors here, it indicates some degraded vegetation. This continues for some zones presently, and we are also able to measure some soil flux of CO2 in these areas, and we do have values which are about 5 times higher than the biogenic typical processes. So we still so this phenomena is still ongoing presently, and we measure the highest CO2 flux during the last campaign in this area, which is probably the last quarter, the quarter of the last phreatic eruptions 200 years ago, and with the highest CO2 measured within this area. And finally, in terms of geochemical observations, basically we have stable measurements and data for at least the past 10 years, and with a more general trend, if we look longer in the past, to a decrease in the temperature of most of the springs and the samples we take. For some of the samples where we sample dissolved gas, we clearly show, especially in Source-Chaude and also within this offshore bubble zone, we clearly see an enrichment. We do with isotope on helium, we see mantle origin of most of the gas that we sample in this area, with a higher mantle origin for the hot springs. Also, they are not so hot anymore, which are close to the volcano. So that's my last slide. So I was a little bit long, but just to give you a flavor of what we plan to do in the future. So in terms of instrumentation, we plan to build 3 new sites within boreholes, which will be multi-instrumentated and hopefully resilient to some natural hazards in the area. We also plan to drill a core to better know the history of eruptions of Mont Pelée and try to access to archives for the last about 25,000 years. We will strengthen our campaign of measuring CO2 soil flux measurements and in a wider area around Mont Pelée. We plan also to make a large passive seismic experiment, because we do not have yet detailed 3D tomographic pictures of Mont Pelée, so that's one of our aim in the future. We also like to set up an onshore geophysical instrumentation a little bit like the one we have for from the marine pool that I presented before, to be able to locally respond to crises or to develop projects, research projects in Martinique, also in other islands, if some of colleagues are interested. And we will try to both strengthen, we'll try to strengthen our research project with human and social sciences, especially to improve the management and the awareness of natural hazards, including, of course, volcanic hazards in Martinique. And last but not the least, we would definitely like to strengthen our collaboration with all the Caribbean partners, and especially with Alpha. Sorry, I was a little bit long, and I leave the floor to Ivan for the Guadeloupe Observatory.
Thank you, Jérôme. Do you see my screen?
Yes, it works, Ivan.
Yeah,
It's okay.
Yeah.
So good afternoon, everybody. So thank you for offering me the opportunity to present the Observatory of Guadeloupe. First, the map on the left reminds you that Guadeloupe is located between Dominica and Montserrat in the northern part of the arc. The observatory is located in the south of the island of Basse-Terre, close to the volcano of La Soufrière. And the observatory is in charge of monitoring the seismic activity in the Guadeloupe archipelago and in the northern French island of Saint-Martin and Saint-Barthélemy, which you can see on the map. As shown in the middle of the screen, the major recent event that caused damages in Guadeloupe is the magnitude 6.3 earthquake that occurred in November 2004 at shallow depth between Guadeloupe and Dominica, in a place where big earthquakes were not expected. On the right, a major task of the observatory is to monitor La Soufrière volcano. This regularly active volcano produced its last phreatic eruption in 1977, and this event led to the evacuation of 73,000 people from the south of Basse-Terre Island. Before the last eruption, the observatory was located on the flank of the Soufrière volcano, only 3 kilometers away from the summit. And you can see the location with the big triangle in black. And after the eruption, it was decided to move the observatory to a safer place on an old volcanic cone 8 kilometers from the summit. And this is shown by the dark arrow on the volcanic hazard map here on the left. And the right panel shows you the new location that allows a nice view on the volcano, but also allows a direct Wi-Fi connection with the volcano instrumental network. From this place, the observatory operates a vast monitoring network that includes 29 seismometers, 30 GNSS stations, and 2 tide gauges. The network covers Guadeloupe Island and the northern French territories. In the right panel, you can see that the network is particularly dense in the southern part of Basse-Terre, and in particular on nearby the Soufrière volcano. In addition to GNSS and seismometer, the volcano activity is monitored by measuring the temperature and chemistry of 12 thermal sources on the flank of the volcano and 5 major fumaroles, as well as the gas plume and boiling lake at the summit. In addition, we monitor in 14 places the opening of the major fault that crosses the dome of La Soufrière. I have problem to switch the slide. It's okay. The sample collected on La Soufrière can be rapidly analyzed thanks to the analytical facility of the observatory. These facilities include a gas source mass spectrometer for the analysis of measure and trace element composition of gases sampled in soda bottles, here shown on the right. An ion chromatograph for the analysis of fluids, including thermal sources, gas condensates, acid lake, and soda bottles. The observatory also uses portable devices for in situ gas measurements, such as multigas for in situ analysis of the gas plume on the top of the volcano, and also an accumulation chamber for the measurement of soil diffuse CO2 degassing. So a very important task of the observatory is to monitor the ongoing volcanic unrest of La Soufrière. On the left of the screen, you can see that the unrest is characterized by a continuous increase of the temperature of the thermal sources that are located close to the dome, and recently a sudden increase of the temperature of summit fumarole, which are for the first time well above the boiling temperature of water, which is about 99 degrees at the summit of the volcano. The composition of gases that are poorly soluble in water, like helium, methane, and hydrogen, records repeated input of magmatic fluids in the shallow hydrothermal system, in particular in 2009, 2014, and 2018. This is shown by the gray vertical band on the left plot. And very importantly, the last 2018 event was also marked by a major seismic crisis, including a magnitude 4 felt earthquake. This major event was attributed to the ascent of magmatic fluids and described by Moretti and co-workers as a failed phreatic eruption. And the ongoing unrest is also characterized by a sustained shallow seismicity, with about 5,000 earthquakes per year at shallow depth, and the deformation of the dome at a rate ranging from 5 to 20 millimeters per year. In parallel, the regional seismological network records between 1 and 2,000 of earthquakes per year. About half of these events are localized and characterized manually by the observatory staff, and they are shown on these maps. On average, 1 earthquake is felt every month in Guadeloupe or in the Northern Islands. For instance, the last major tectonic event in Guadeloupe was a magnitude 6 earthquake that occurred in December 2023, 50 kilometers to the north of La Désirade Island. This is the panel on the right. Finally, the observatory disseminates information in monthly bulletin, where you can find information on the activity of La Soufrière volcano and regional seismic activity. Depending on the activity, we provide information releases about the sequence of earthquake of La Soufrière and earthquakes felt in Guadeloupe and Northern Islands. We also summarize all information in annual reports, and all documents are available on the OVSG website, which can where you can also find information on the staff and project. Thank you.
Thank you for this very interesting presentation, Dr. Ivan and Christophe and Jerome. And now if you have any questions, I mean, of the participants, you can raise your hand or write in the chat, and I will read the questions, please. So please go ahead. Okay, Lisette. Hi, Lisette. Lisette say hi to the presenters and thank you for accepting the invitation for presenting. I wanted to ask Elske about the perception of the risk in Saba and St. It's a good question. As there is no historic activity, are the people in the islands, oh, sorry, hiding. Okay. Aware of the potential volcanic hazard, or is it often something that will never happen, as there have not been any unrest historically?
Yes, thank you for your question, Lisette. The people on the islands are actually very much aware of the fact that they live on a volcano. So even so much that before we started actively expanding the monitoring network, they were really asking if they could please have a monitoring network, and they didn't feel that enough was being done to monitor these volcanoes. So since 2010, these islands became special municipalities, and since then things have progressed. And we spend a lot of effort to disseminate our findings and our work to the people living on the island. And I mean, we can still do more, but I think they're very much aware. Yes.
Thank you. I had a similar question actually for, okay, not as similar, but for the doctors also. How the people see the volcanic hazard in, for example, in Martinique or in Montserrat?
Perhaps I can comment quickly for Martinique, but perhaps Jean-Christophe, who has much more experience than myself about the awareness of people, can complement. I would say that for Martinique, the fact that there was these eruptions in 1902 and 1929 is still quite present in the memories, but it does not mean that everybody is aware of the present hazard related to the volcano. I would say that some people tend to think that it will only affect really specific areas, and for example, it's probably there's probably a lot of work to do to make people so that they are aware that it can influence a much wider area than the only Saint-Pierre town or the pressure towns which were affected, which are shown by images and stuff like that. So that's one of the reasons why we would like to develop, as I said, some projects with, especially with human and social sciences, to have new ways to interact both with authorities, politics, but also with the public, and see how we can improve this awareness and try to perhaps see what are the best practices which are used in other islands or in the Caribbean region to have new ways to work on this awareness.
Thank you. Jean-Christophe?
Yes, thank you very much, Jérôme. Just to add some information, I think the biggest challenge that we have in Martinique and also in Guadeloupe and probably also in other places, but specific, I think it's specifically marked in the French islands, is that there is this general paradigm by the authorities that you can only respond to a volcanic eruption by evacuation. And so there's actually the trauma of the evacuation and the destructions linked to the magmatic eruption in Montpellier, but also to what has been perceived by the population largely as a not useful, a failed management of the crisis in 1976 in La Soufrière, which led to the evacuation of about 70,000 people for about 6 months. And so people are fearing that they will have to evacuate in a long time because they don't perceive enough from the authorities that the authorities have a plan to manage evacuations, but also the authorities do not want to consider other actions, and we are having difficulties to try to to raise their awareness that volcanic activity is linked to imbricated scales, both in times and space. So at the beginning of the eruption or during high activity, of course, there are areas that will have to be evacuated, but that doesn't mean that the entire island of Martinique or Guadeloupe has to be evacuated. So authorities have to consider evacuation, but they also have to consider, as you go away from the area or as the activity fluctuates, different types of responses, living with some nuisances or some dysfunction of the systems, and not just evacuating everyone. And we're having this very contrasted, very contrasted, arbitrary mode of thinking, and we're trying to raise the awareness of gradations, zones of hazards, and therefore of responses, and not this on-off type perception and response. So that's our biggest challenge, I think, one of the biggest challenges.
Oh, thank you. It's quite different in each place. Thank you so much. We have another question here from, it's one of the drawbacks of volcanoes on island is that have a network very close to the volcano, but an advantage is that they can more easily carry out geophysics campaigns. As you showed, okay, how often are campaigns carried out to have 2D and 3D models, and what is the collaboration with the observatories in the other entities?
Yeah,
Yeah,
sorry,
Ivan,
I'm not sure I got the question. So you mean how often do we do campaigns and on repeating measurement sites, or?
Sorry? Okay. Say, how often are campaigns carried out to have 2D and 3D models, and what I think probably is how is the collaboration with the other islands? He means probably to seismic campaigns, maybe. This
Yes,
is
okay. So quickly for Martinique, I mean, that's what I mentioned in the conclusion, is that we are, in terms of seismic imaging, we definitely lack some temporary experiments to provide a 2D or 3D model of the interior of Montpellier. So that's why we plan to do one with some probably based on the nodal seismic sensors, because now we have this opportunity to have much cheaper, but also much more easier sensors to install. So that's the plan for the future. We started already 2 years ago with some local antenna, but mostly dedicated to better understand the origin of the volcanotectonic activity that we have on the island. So yeah, so we don't have repetitive, up to now at least, repetitive seismic surveys apart from the permanent stations that we do have on the island.
okay. And how about the geophysics campaigns? Do you have to perform often? Or?
So I think Ivan can comment on that for La Soufrière de Guadeloupe, because there were quite a lot of geophysical campaigns. At least for Martinique, there have been some magnetotelluric campaigns which were performed by collaborators from the Geological Survey of France. And we will develop collaboration, especially to compare MT imaging, resistivity imaging with seismic imaging in the future.
Yes, in Guadeloupe, we have different tomography of the volcano using classical method, electricity, muon tomography, and also a project for electromagnetic tomography. But this campaign, they occurred only once. It means that we have not a time evolution of the tomography. Only for the electric resistivity, there was a campaign. Jean-Christophe will perhaps detail more on this point. There was a campaign, I think 10 or 15 years ago, and now last year there was a new campaign. So it means that we will be able to compare the tomography today to that of 15 years ago.
Yeah, just to add a few words, these geophysical campaigns are obviously quite challenging to develop. So we're having difficulties actually getting funding to have these campaigns on a repetitive mode. But the repetitive electrical conductivity campaigns are going to be only for the upper parts, the last 20 meters. And there have been two campaigns, one 2 years ago and one just a few months ago. But the campaign that Ivan mentioned that was done 10 years ago actually is the first model was produced using several years of campaign, but only on a specific specific profile. So it's clearly a challenge that we have set for both observatories. One very successful seismic antenna experiment was done in Guadeloupe about 4 or 5 years ago, and we are going to submit a publication has just been accepted, so it should be out, I think, we hope in perhaps within 1 or 2 months. And that's an experiment that Arnaud Burtin and colleagues did in Guadeloupe with about 80 seismic nodes on the upper flanks of the La Soufrière. And this shows an extremely promising technique of processing the data, and we're able to image with about 100-meter resolution down to 10 kilometers depth and over about 4 kilometers width. So we actually see the plumbing system of La Soufrière. So this is probably the first time that this has ever been made in the world on a volcano with this high resolution. And this is something that Jérôme, who is specialized in geophysical imaging, seismic geophysical imaging, would like to develop for Montpellier. So right, we have the first results, but it's obviously not yet operational for repetitive surveys and collaboration in the Antilles. That would be probably quite an interesting project that perhaps could be proposed to European funding, for example, to be able to have the equipment, and I think Jérôme mentioned this a little bit in his presentation, to be able to do this, both the equipment and the staff on several volcanoes in the Caribbean every few years, because you probably don't need to do this every year, but if you can do it every 2 or 3 years on La Soufrière or Montpellier or other volcanoes for like 10 years, then you will start to have a very interesting data. So it's clearly something that we should, I think, further discuss within the Eastern Caribbean and perhaps in the framework of ALVO, for example.
So sorry, I lost my connection. I'm back here. Okay. Well, thank you so much for your participation, doctors. Oh, Lisette have another question. Sorry, okay. Lisette say my other question is if there are opportunities for students interested in volunteering or working temporarily for experience or something like that in the islands. And thank you, Lisette.
Yeah, quickly for Martinique, I think it's the same for Guadeloupe. We have some facilities to welcome some students and collaborators. At least we have some rooms available in the observatory, etc. The only, as usual, the only problem is the funding usually for that. But yeah, definitely we are welcome to discuss collaborations and welcome students or people who are interested to develop their activities and bring their knowledge also to the observatories.
Right. Thank you. Okay. So if you have any questions, it's the moment. And if not, we just would like to say thank you again for the participants. Okay. Elske is answering also. Say we unfortunately don't have any such at this time. Okay, thank you, Elske. Or Elske. Okay, so I think we are done here. I don't see any more questions. So thank you so much again. Jimmy, say great presentation. Thank you. And on behalf of ALBO, I like to thank you again and again for your participation, and to the presenters and all the participants for your questions. And I want to invite you to check the presentation at YouTube or share it if you want. And I want to invite you to follow ALBO social networks also, to keep participating in this kind of activities. So have a very, very good day, and thank you so much.
Thank you very much. This was very nice. Thank you.
Thank
Thank
you.
you.
Thank you. Bye-bye.
Bye.
Bye-bye.
Bye. Everybody say thank you in the chat. Thank you. Bye-bye.
Bye.